Matthew, come on up and tell us all about maximizing flow.
I will, thank you. Okay, my name is Matthew Inman Cochrane. You can call me Matt. I am from Simple, a software engineer there, and I'm going to talk about maximizing flow. That is delivering value to customers and doing that with mob programming, how mob programming relates to it, really. So I originally named this talk for the concept of equilibrium. That is when opposing forces are in balance. But I realize there's a misunderstanding with this idea that I want to get out of the way at the beginning of this talk. It is instinctive, I find, to think about the forces at play in software development as specifically being velocity and quality. But those who have built high-quality software will tell you that quality code yields faster development and greater agility. Here are several examples, but it's a lot of text. I'll just point out, for example, Bob Martin's "The only way to go fast is to go well." I think I'm preaching to the choir here. This is a community of quality-oriented people after all. But I wanted to underscore this before proceeding, and I can point out these tweets again later on tonight. So equilibrium, right? Equilibrium is stagnant, I want to point out. Like this stagnant water here, it's not actually what we want. What we want is flow. I'm sorry, flow. Thank you, I know it's forced. Oh well. So, to maximize flow, which again is delivering value to customers, we need a few things. First, we need this understanding that we've just talked about, that quality code helps in the flow of value to customers. Quality is like the slope of a river when it comes to flow. Second, we need to maximize the capabilities of a team. Third, we need to minimize waste in the process of development and delivery. Waste here sounds like a loaded term. Waste, I mean in the formal lean sense, which is that which does not deliver value to customers or produce value that goes to customers, okay? So, my thesis is this. When addressing these things, if you have a culture of quality, if you do smart things to maximize the capabilities of your team, and if you minimize waste with smart strategies, what you're left with is mob programming, trying to invert the way that we get here. So let's talk about maximizing capabilities. Teams are, of course, capable when they are knowledgeable about the domain, about their tools, languages, architectures, when they're skilled in communicating and programming. And this is key when they are aware of what they do and don't know. That's going to come up. The most accessible way to increase a team's capabilities is to have team members learn from each other. That knowledge is already on hand. So if you get everybody together and make sure that they're communicating consistently their knowledge with each other, you're heading toward mob programming. So mob programming, in which team members develop together on a single computer, results in continuous distribution of their existing knowledge. Everyone, oh, whoops, went forward too fast. With this continuous distribution of knowledge, everyone learns from each other, even to the point, I want to point out, where a specialist doesn't always have to be in the room in order to accomplish something that they're a specialist in. For example, the web developer may not be present on a day, but a mob programming team can still change the behavior of a button or add a new link and deploy it. Additionally, and this is the awareness thing, knowledge gaps among the team are surfaced faster when they're all working together. If you surface knowledge gaps faster, you get to address them faster and get the benefit of the knowledge that the team needs. You get to maximize capabilities higher and sooner. Okay, to defects here. Oh, we got We got a little keynote to PowerPoint change here. This says minimize defects at the top in giant letters, believe me. So to minimize waste, we're going to start with defects. Defects inhibit flow, like these rocks. They expose areas of low quality. When an expected behavior fails, the waste incurred is significant. Time spent fixing the defect is not only time correcting old code, it is time not spent developing new things of value. It carries opportunity cost. Additionally, the time that the expected behavior is broken is a negative value to customers. So a great way to minimize defects is continuous code review. Like XP does with pair programming, where the idea was, well, let's take the extreme version of code review and do it all the time with each other, okay? That is going to minimize defects and increase quality, kind of the same thing. Additionally, if you have everybody with relevant knowledge doing the continuous code review, that moves you toward mob programming. Don't build the wrong thing. So this river, for example, could have maximized flow by going through this wall at the top instead of this big loop around, right? Don't build the wrong thing. Think back to the last time that you heard, that's not what I meant, or I'm not sure that this change will accomplish what it's supposed to. A good way to lower the chances of wrong work is to have the entire team align on what needs to change in the software to accomplish its goal. This becomes more powerful if the entire team is continuously checking on whether the work in progress is doing that, is accomplishing its goal. A mob programming team does that too. So let's look at an example. Here's a story. Customer can switch to dark mode via their profile menu. Here's a plan. Add a toggle switch to the profile menu. This is a plan of what to do to the software. And many teams get here, and that's good. But then they assign work and go their separate ways. Here's a test. So a mob programming team continuously ensures that they're building the right thing by aligning on what they mean in code, not just in a meeting, and not just in Jira, but by expressing their alignment in actual code. And that is so key. Bottlenecks are next. Again, giant text. It says minimize bottlenecks. So bottlenecks define the maximum possible flow. Quite simply, they should be eliminated. A QA silo is a bottleneck. We can't deliver faster than dedicated individuals can perform review. It's simple. A design phase is a bottleneck, where we have to wait on decisions that may even change later on before delivering something. If only a single team member, for example, can actually release the software, that's a bottleneck too. So if a team eliminates all bottlenecks, I'm going to contend that that probably means that they are continuously collaborating all together, from concept, like design phase, to delivery, all the way through testing. So in a cross-functional mob programming team, everyone can contribute design ideas, everyone can type code, and everyone can test. I'm happy to describe in more detail what sort of mob programming practices mean that a Scrum Master is typing code. It's a real thing, I promise. Asynchrony. Up here in the corner, this says minimize asynchrony, but I think that this shot of the Ganges River says it all too. Asynchrony is multiple streams of work operating concurrently. In computing, we use multiple processor cores to run things in parallel, right? And that usually makes computers faster. So if a development team were like a CPU, we could add 50 cores and then produce software 10 times as fast, right? But like all of us already know that that's not true. That's not the way that things work. In fact, even in the study of asynchronous computing, what we find is that when parallel processes have to communicate with each other along the way, that can be slower than synchronous processes where one operation cannot start until the last one is finished. So asynchrony on a team means lots of interactions between work in different contexts. It means waiting for answers from team members, dependency management and mistakes. It means multiple rounds of code review, which as a software engineer, let me tell you, is exhausting. And it means merge conflicts, my bane. Asynchrony can be eliminated by collaborating synchronously, working on one thing at a time. So my thesis was this: the natural landing point of maximizing capabilities and minimizing waste is mob programming. That is, if you take the status quo with its existing capabilities and wastes, and you add continuous distribution of knowledge, you add prompt identification and resolution of knowledge gaps, you have a whole team checking for defects as all changes are made, the whole team works to resolve all defects, the whole team is aligned on what to do and how to do it before and during changes. If a whole team is capable of moving work forward because they don't have bottlenecks, and if you have a team that does one thing at a time, what you're left with is mob programming with increased capabilities and minimized wastes and maximal flow. Thank you.